Hello, we're going to spend a few minutes adding and subtracting complex numbers. These are the numbers that have the I in them that represents an imaginary component. And we are going to treat the I just like we would with any variable when we do the math. Now, I like to think of this in terms of my regular algebra that I do. If I were to simply do 3x plus 4x, every single one of you would know that that is 7x. If I did 3 pi plus 7 pi, or not 7 pi, 4 pi, you would also know that that was 7 pi. So in the same way, if I did 3i plus 4i, I'm sure you can see the pattern, we have 7i. All right, so let's do some of the math here below. In A, I need to add my real number components, the 7 and the 5 for 12, and then the imaginary component, the 3i and the minus 4i for negative I. Now, we have left that answer in what we call the standard form of a complex number, which is A plus BI. A is the real number part, BI is the imaginary part. Let's work on B. First, we need to distribute the negative. That's a negative 5 plus 2i. And combining like terms, the 3 and the negative 5 is negative 2. And the 4i with the 2i makes 6i. So negative 2 plus 6i is my complex answer. Negative 2 is the real part. 6i is the imaginary part. In C, again, let's distribute the negative on the second term. That makes 3 minus 5i. Adding up like terms, we have 3 plus 2 is 5. And then we have on the imaginary parts, 4i minus 5i, that's not negative i, and negative i minus 6i. Altogether, we have negative 7i. So my complex number is 5 minus 7i. On the last one, D, let's distribute the negative on the last term, giving me minus 8 minus 3i. And combining like terms, we have 5 plus 3 is 8, minus 8 is 0. And for the imaginary part, negative I plus 4i is 3i, minus 3i, again, giving us 0 i's. So altogether, that is just 0. No real number part or imaginary part.